Modern datasets often contain hundreds or even thousands of features. While more information can improve predictions, it also increases complexity, computational cost, and redundancy. Principal component analysis helps us simplify the data without losing its essential structure. Every feature represents one dimension of the dataset. As dimensions increase, visualizing and analyzing the data becomes increasingly difficult. Not every direction contains the same amount of information. PCA searches for the direction where the data varies the most. This direction captures the strongest underlying pattern in the dataset. The direction containing the greatest amount of variance becomes the first principal component. For this cloud, that single axis preserves 94% of all the variance. After finding the first principal component, PCA searches for another direction that captures the remaining information while remaining independent of the first. Together, these components preserve the full structure of this two-dimensional cloud, and in high dimensions, a few components routinely preserve most of it. Instead of working with thousands of features, PCA represents the data using only a handful of principal components. Typically, most of the important information survives. Storage shrinks and training gets dramatically faster. Dimensionality reduction makes machine learning models faster, reduces storage requirements, simplifies visualization, and often improves generalization by removing redundant information. Let's recap. Every feature is a dimension, and too many dimensions slow everything down. Variance shows where the information lies. The principal components are the directions of greatest variance, and keeping just the first few preserves most of the structure. Principal component analysis is used wherever high-dimensional data must be simplified. It plays an important role in computer vision, healthcare, genomics, finance, robotics, and scientific research. PCA simplifies complex datasets before learning begins. But what if we could improve predictions by allowing each new model to learn from the mistakes of the previous one? In the next episode, we'll explore gradient boosting, one of the most powerful predictive techniques in modern machine learning.